Welcome to the TouchDevelop video, Sprites First Steps, in which we cover the introductory creation of sprites and 4 of their capabilities. Sprites are visuals that may be maneuvered on screen and are commonly used in a variety of joystick games. Starting in the main method, we will get familiar with creating our own of such objects. Entering our first line as a command, we will initiate this learning app artistically. Calling the wall and changing its color to cyan will allow our sprites to stand out. Since we will be altering size and opacity, black sprites will best visualize our intent through drastic contrast. On our next line, we enter a variable. This variable will become our board, a required backdrop for the sprites as they are gaming components. To initialize, we enter the library Media and then find the option Create Full Board. Knowing we will be using our board in future code, we promote it to a global. Beneath our board's declaration, we will create our first sprite through a variable. Calling data board and then create rectangle forms a rectangular sprite with the width and height matching the parameters in pixels. We choose to enlarge the sprite as an optical aid and then promote it as well to a global. Below, we command the sprite's position. Since it will share the screen with 4 other rectangles, we center it horizontally by taking the board's width and then dividing it by 2. Vertically, we choose to place it 100 pixels in order to leave room for the sprites to come. As said before, the sprites will be black for effect, so we script the command data sprite set color and replace colors to random with colors black. We now repeat these steps to create the remaining 3 sprites, with the only difference being the Y value of the set position line. Each rectangle's edge will be 100 pixels from its predecessor, and since position refers to the center point of the sprite, we add the 100 pixel distance to the 50 pixel borders of the 2 involved sprites. So our first sprite had the Y value 100, which means sprite 2 has the Y value 300, and sprite 3 follows with the Y value 500. Sprite 4 finalizes with the value 700. The code creating each of these sprites individually is lengthy, and in order to make it all visible to the user, we have to post its entirety to the screen. Luckily, we can enter the command, which takes the board and all of its contents and posts it to the wall. Having characterized and placed our 4 sprites, we must create the reactions to the user. This will be done entirely through events, each of which will run when the corresponding sprite is tapped. In the body of tap sprite, referencing our initial sprite, there will be 2 commands. The first alters the sprite directly, so we take data, sprite, and tell it to set opacity. Opacity is a set decimal between 0 and 1, 1 being the darkest and 0 being completely invisible. By setting the parameter to data, sprite, opacity, we extract the present opacity value, and then, by subtracting 0.05, we cause a gradual fade each time sprite is pressed. Our second command simply instructs data board to update on wall, so that all changes are detectable as they occur. Now that we have learned our first sprite implementation, let's move on to more advanced changes. The next event will be tap sprite 2, and we'll have 3 commands that occur when that sprite is tapped. The first orders the second rectangle to set width and adds 5 to the current width via data sprite 2 width and adding 5. We then repeat this line below with the height via data sprite 2 set height and then the parameter data sprite 2 height plus 5. As with the previous case, we close our event with data board update on wall, so the user can see all changes that are being made. Already, we have learned 2 important skills involving the modification of sprites. Still, let's expand our knowledge 2 possibilities further. In the new method, tap sprite 3, we will be rotating our object in its place with 2 lines. To do this, we use the option set angle, whose parameter is taken in degrees. We present the current angle of sprite 3 or data sprite 3 angle and add an additional 30 degrees to rotate it. After finishing up with the constant board update on wall, we then continue on to our 4th and final event, tap sprite 4. Tap sprite 4, our last rectangle reaction, is the longest of events with a total of 5 lines, each of which is a simple yet useful concept in game creation. Inside Tap Sprite 4, we will be making our sprite disappear and then reappear again on the screen. To do this, we draw from Sprite 4 and tell it directly to hide. Now, so the user knows it has been hidden, we update the board. Since we cannot trigger the sprite to disappear and then reappear instantaneously with a noticeable change, our third command enters the section time and then tells the entire app to sleep for 1/4 of a second. Sleep is computer science terminology for pause, as the entire method simply stops for the duration of the input parameter. After the line involving sleep, we then return Sprite 4 to the screen through the counter command of hide, show. Once and for all, we sum up our event with data, board, update on wall so that the user may see all of our changes. Each rectangle now has a set color, position, and reaction to the user, which we can test by running our script.